Hello, hi, good afternoon. So this is Krishnaveni and we have been talking about the story of life on earth and that's biology. So welcome all of you to my session. Hi Vinu, yes, hello, good afternoon. So did you have lunch? So did you come to my Sunday's lecture? I guess you were missing. Is that so? Yes, Harini, good afternoon. So thank you so much for joining my session. So once again, for all those who are new, so Monday, Wednesday and Friday, I teach for class 12 and for the remaining 3 days, I teach for class 11. That is Tuesday, Thursday and Saturday. All right. Yes, so did you watch my recorded lecture? So we were talking about your animal tissues and we are done with that chapter. You was not well. Okay, you were not well. All right, so please take care. Are you fine now? Satyendra Kumar Singh. So hi, hello, so good afternoon. So thank you so much for joining my lecture today. My sound is not clear. It's not audible enough. Now is it audible? Yes. Is it clear to everyone what I'm speaking? Vinu, is it clear now? All right, so we are here in the second week of February. So 1 week in February has quickly flown away. Yes. So here we are talking about lecture 6 of ecology. So we will take one more lecture to complete the first chapter in ecology. So we have been talking about organism and population. Yes, so I will take one more lecture to complete that. So before that, today's lecture. Yes, so it's a very interesting chapter if you study it from a person who loved biology than for a person studying for marks. Okay. Yes, so where were we in ecology? So any idea? So did you all like my Saturday session at 7 p.m.? So we were talking about mental health, right? Yes. So did you all follow? So today, are you mentally fine? Are you mentally fit? Are you suffering from a mental disorder? Are you suffering from a mental illness? Yes. Any benefits of having a session like that? Or you just listen and you just forget? Is that so? Or is there any benefit? Is there any use of having the session? Yes. Yes, for all those who were attending my session and all those who saw my recorded lecture later about mental health. So did you find it useful? Was it interesting enough? Yes. It was worth it? No? Okay, so if you haven't watched it, please do watch it. Yes, ma'am, good afternoon. So thank you so much for joining my session today. So hope you had lunch. Yes, so we are here, we are in ecology. So let's try to finish it off quickly so that even you'll be free and I'll be free. Yes. So yes, so which means Vinu says he has seen the lecture. So sorry, he has seen the live session at 7. Yes, I guess you were not live, but you had seen my recorded lecture, recorded video. Yes. So did you like it about mental health? So every Saturday 7 p.m. we talk about something apart from biology, apart from NEET, apart from NCERT, so that we have a session where you can share out your problems, shout out your problems, so that I can give you suggestions or motivation, something like that. Okay? Yes, come on now, quickly like, share and subscribe. So all those who are watching, quickly share my session, do like it and do subscribe it. If you have not subscribed, come on, make it quick. So it's 3-6. Yes, you like it. So thank you so much. So if you're not shared it, come on, quick. Yes, so it's 3-6, so 3-8 till 3-8 I will wait. So come on, quickly let your friends know that I'm teaching ecology and we're almost in organism and almost towards the end of this chapter. And another lecture will be done. So by Wednesday we'll be done with this chapter and then we'll move forward to the next chapter. All right, yes. So do you have any suggestion as to which chapter you want me? Of course, I am planning to finish off ecology in one go. Is that fine? Or do you have some other suggestion? Because we are done with the major chunk, that is genetics. We are done with microbes in human welfare. We were done with human health and disease. We were also done with your strategies for enhancement of fruit production. Next, we also spoke about your biotechnology. So all that is left is your first unit, that is reproduction. And the other one is ecology. So I started off with ecology. So do you have some suggestions in mind? Do you have some other doubts, some other questions? So if you have, so please do put it here. And apart from that, in my description box, you have a link to join the Telegram group of eCareerPoint. So do join. Yes, so that you get to contact faculties instantly for your doubts. Okay. Yes, so we were here talking about organism and population. So I defined ecology. So what was ecology? So why are we talking about ecology? So why should we talk about ecology? So what will happen if there's nothing called as ecology? So still life would persist the same. So then why should we talk about ecology? So why is it important? So first of all, tell me, what is ecology? So we have been talking about ecology for the last 1 week, right? So almost 2 weeks, because today is lecture 6, so almost 5 lectures we have been talking about ecology. So what is ecology and why should we study about ecology? So every chapter that is given in your NCERT book has a reason behind why it is given. So you'll understand it not now, but a few years later as to why did you actually study. Now tell me, what is ecology? Come on, quick. So all those who are watching, quickly define ecology for me and tell me why it is significant. Why should we study ecology? Can life not survive without us studying about ecology? So we were not studying about ecology for a few days when life was existing on Earth, right? But still life existed in the normal, usual way. Then why should we talk about ecology? So only when you answer these questions as to why, what, and how, then you'll understand the importance and then you have an interest to study the chapter. So ensure, so whenever you're studying something, don't study it like a blind horse. So make sure you have some reason behind why you have to study and how you can make the chapter interesting according to yourself, because at the end of the day you should study and not me. I can only teach you, and ecology is a chapter that I can tell you a lot of stories about a lot of animals, that's fine, but at the end of the day you have to study. Yes, so here we have the definition. So ecology is the branch of biology that deals with the relations of organisms to one another and to their physical surroundings. Yes, exactly, you're right. So ecology is a study of organism and the interaction of the organism along with its environment. Yes, so that is called as ecology. Yes, you're absolutely right. So thank you so much, Vinu. And ecology is absolutely necessary for to understand how an ecosystem works, to understand how an environment actually works. Yes, so if you do not understand, so you do not know where you're going wrong, so eventually we'll meet the deadline very soon. Okay, yes, so that is the reason. So am I fast? So should I slow down? Yes. So Anthony, Abhi, are you watching my lecture silently? So tell me if I have to slow down. All right. Yes. Okay. So what were the topics that we were dealing with? The first one was introduction. So I told you why ecology is important. What is the highlight? What is the emphasis of ecology? Then organism in its environment. So we spoke about various organisms and how they are getting adapted to a particular environment. Then, so what are the factors that are affecting a particular environment? For example, so once again I'm repeating, so biomacromolecules. So biomacromolecules are your carbohydrates, proteins, lipids. So they make up your cell. So the major constituents of a cell are your biomacromolecules. So a group of cell makes up a tissue and a group of tissue makes up your organ, and a group of organ makes up your organ system, and an organ system makes up an entire individual. So two or more individuals make up a population. So two or more population makes up a community, and two or more communities make up a biome. For example, when I talk about desert, so desert is a separate biome. When I am talking about a Himalayan region that is filled with your snow frost, it is another biome. Yes, so the animals or the living organisms living in a desert and those living in a Himalayan region are completely different, right? So that is, the organism is developed according to the surrounding, according to the environment. That is organism and its environment. So what are the abiotic factors that is affecting the life of an organism? So we spoke about 4 things, that is temperature, soil, water, etc. Right? Yes, Anthony, Habi, yes, good afternoon, or very, very happy good afternoon. So thank you so much for joining my session. So just now I was talking about you and you are here. So let me know if I have to slow down. So for all those who are watching, please do let me know if I have to reduce my speed. And if you're taking notes, please do let me know so that I will pause in between so that you can take notes. All right? Yes. So is my speed fine? So can I go in this speed? So am I too fast for you to comprehend? Yes. Are you trying to contemplate what I'm saying? Or does it look like a foreign language and an alien class to you? Yes, the speed is fine. Or so the yes is for what? Yes is to slow down or to say the speed is fine? Okay, so do let me know. So that's what we have been talking about. Okay, so we spoke about major abiotic factors, but how do we respond to these abiotic factors? So it all started. So you want me to reduce my speed? All right. Okay. Okay. So what are the response to your abiotic factors? So what have we been talking? How do we respond to your abiotic factor? Number 1, we regulate ourselves. We conform, we migrate, or we suspend. Yes. Okay, so I am slowing down, so don't worry. So these are the ways by which we respond to the abiotic factors. Regulate, for example, that's when we spoke about the altitude sickness, right? Yes, what is altitude sickness? So suddenly when you go to a place like Manali, when you go to a higher region, for example, your Rohtang Pass, suddenly you have difficulty in breathing. So why? What happens? At such a high level, so the amount of oxygen that you receive is pretty less. So your body has to regulate according to the temperature outside. So eventually you try to become normal, right? It's not that you're always suffocating for breath. So initially, just say for 1.5 hours or 2 hours, your body takes time to adjust, but otherwise you're absolutely fine. So our body is trying to regulate, so that is regulate according to the temperature outside, according to the abiotic environment outside. Yes, for example, migrates, when birds migrate during the cold season, yes, they migrate from some Arctic regions to your Bharatpur sanctuary that is here in Rajasthan. Yes, so all that happens and suspend. So when animals finally decide, okay, so I'm not going to be in this unfavorable season, so I'm going to escape this unfavorable season, that is when your when your bears hibernate. Yes, your fishes estivate. So these are some of the ways by which they can escape the unfavorable conditions. Sometimes we're able to adjust, sometimes we try to escape the situation, right? So it so happens with us. Sometimes we try to adjust with this person, sometimes we cannot tolerate, we are trying to escape. The same is the case in nature. All right. Yes. And literally this way by which they respond to the abiotic factors are by means of adaptation of a particular animal, right? For example, if I say your polar bears and your other animals which is living in the snow regions, they have certain types of adaptations. So they, in a way, they're responding to the abiotic factors, right? So this is the environment, so this is how they're going to survive. But at the end of the day, it is the survival of the fittest, to how well they can survive, how well they can persist their progeny. So that's what matters, right? So here, one adaptation that we always been talking about is your Allen's rule. So what is Allen's rule? So animals living in your cold regions, they have your shorter palms and shorter limbs. So does polar bear have a long ears like your elephant? Definitely not. So why do they have your short limbs and short ears? To reduce the surface area. So by reducing the surface area, the amount of heat that is lost is less. All right. Yes. So that is the main reason. So that is adaptation. Then we went on to talk about population. So what is a population? So does population have a particular attribute or not? So that's what we have been talking about in population. Then population attributes, yes, the properties of a population. So what were the properties of a population? So when I say a population, so you have two attributes. One is that you talk about your birth rate and death rate. Yes. The next attribute of your population is no, exactly, your organism and population is a huge chapter. So ecosystem, biodiversity, I will not take much longer time. Maybe much before that also we can finish, 1 or 2 lectures before February and also we can finish. So don't worry. Then I'll start off with reproduction. So reproduction will be done by mid-March. Then we'll be done with your entire 12th syllabus. So parallelly we are doing your 11th also. So in 11th, we will very soon enter your human physiology after cockroach. So I'll be teaching cockroach tomorrow and then we'll be entering human physiology. So plant physiology is left. I'll try to finish by the end of March. Okay. So by the end of March, both your class 11 and class 12 chapters will be done. Okay. I will try to finish as much as possible. Of course, your 12th is much easier to complete compared to your 11th, right? All right. So that is one attribute, that is your birth and your death rate. The second attribute is about the sex ratio, if you remember. Yes, so these are the two things that we were talking about, a population attribute. The next one is population growth. How do you know this particular population is stably growing? How do you know what pattern this population is following? So we have population growth models, right? So we spoke about two models. One is your logistic growth. The other one is your exponential growth. Yes, so we will talk about both of this. So your exam is mostly in the month of June, right? So during the May month, you have your board exams going on. So tentatively, it should be in the month of June, right? So that is my guess. So if it's in the month of June, so you should have the last 2 months for revision. So last 2 months, you should repeatedly take a lot of questions. You should keep revising. So I suggest you by the mid-April, so be thorough with at least 80% of your syllabus. Okay, so that is one way you can ensure. Only when you do repeated revisions, only when you do repeated question solving, you will become confident with how you're going to approach the question. So even if the paper is very tough by chance, so it does not matter. So you still have, we are in the mid-February right now. So we have March and April. So you can take entire March and April, yes, to complete your syllabus, but ensure by April you'll be done with this. All right, so we have almost 38 chapters in biology. So please quicken up your pace. So by the end of April, so make sure you'll be done with your syllabus. So only when you say by the end of April, so plus or minus 1 week you will take. Yes, so by the time you finish the entire syllabus, you will get 1 round of confidence. But start revising. So how will you revise? You will not take the same time that you took to study this chapter for revision as well. If you're taking 2 hours to study a chapter, you will revise it in half an hour. So that is the efficiency that you should show. So when you're reading something, read it properly. So always have this habit, when you're doing something, do it properly in one go. So don't leave bits and portions here, so that will not help. So that is not how you should proceed with a proper planning. Okay, so make sure when you're revising, you should take only half an hour if you initially took 2 hours to finish the chapter. All right, so that should be a strategy. And towards one point, you will only start taking tests. So initially start taking chapter wise tests. Yes, you have a lot of chapter wise tests in our app also. Okay, yes, if application starts from July, then we have hell a lot of time. So you can take till mid-May to finish. Yes, but if you are preparing for boards, then the May month will go in your board exam. Yes, so your April will be your deadline, obviously. So plan accordingly. So first, if you're done with the chapters, so start taking first start solving question. For example, for every chapter, you might have some questions with you, right? At least 100 questions. So first solve the 100 questions. So once you're done, take a chapter test. You have a lot of chapter tests in eCareerPoint app. So according to the chapter, start taking tests. So when you take a test, you will know where you stand. So when you complete a particular unit, again, take a test. For example, when you complete ecology fully, take up a test. When you complete genetics fully, take up a test. Okay. So at the end of every chapter, you will solve questions, and at the end of every chapter, you will attend the chapter test as well, and at the end of every unit also you will start attending tests. Yes, you have a lot of websites, you have it in eCareerPoint app as well. So find out the chapter and take up the test, so you will know where you are going wrong. So only when you can cross 80% in each chapter test, it ensures you're perfectly done with the chapter. All right, so try doing that. So when you're done with 2 units, take the test for both the units. Okay, so try to find some questions accordingly. So that is the way you should revise. Don't just do a blind horse work of just studying. Okay, so that will not help. Okay, yes, so make sure your timetable is effective and you're being productive enough. So that is very, very important. So that is the ultimate formula for success: how efficient you are and how smartly you plan. Okay, yes. Yes, fine. Okay, so that is also a good way. NTA app also has a lot of questions. Yes, even I have seen. So start solving. Okay, yes. Yes, even I saw that your education minister is mulling over the idea of conducting the exam twice. So let's see. So if it's twice, then one will be in the month of July, the other one will be in the month of December, most probably. So let's see what they have to tell us. So as long as you don't get a final decision, please don't pay attention. Just be casual, just start preparing. So don't waste time on all this. So anyways, you're going to have an exam and you're going to write the exam. So start preparing. So spend time in that. All right. Okay. Yes. So we were talking about population growth, whether the population is increasing, decreasing. So what is the pattern of this population, etc. So we spoke about population models, if you remember. So one was logistic model, the other was your exponential model. Yes. So let me continue from here. We are talking about population growth. Yes, the size of a population for any species is not a static parameter. Static is at rest, right? So the size of a population is not constant always. It keeps changing. Obviously, even if you have 10 dogs in your street, so every day the population keeps changing. Either one dies or the one gives a puppy or another dog from another population comes into picture. Yes, the size of a population is never stable and it is not a static parameter. So point number 2, it keeps changing with time and it depends on a various factor, not just one or two factor, but it depends on a various factors. So it depends on the food availability. For example, if this street has so many options for food, so many houses are giving food to the dogs, then this street will have more population. Yes, they migrate based on food availability. Then predation pressure Yes, if this dog is a very introvert dog and it's facing a lot of bullying from the other dogs, so it will come to an area where no one is disturbing it. Yes, that is predation pressure and adverse weather. Yes, so if it can find shelter in this particular street, yes, obviously it will move. So that is also a criteria for adverse weather. So these are the criteria on which the size of a population keeps changing, and thus it is not a static parameter. So whether it is flourishing or declining, we'll know from the population. Yes. So from the size of population, we'll know whether it's a flourishing population or a declining population. Okay. So what is density of a population? So technically, so you have population size. So technical term of population size is your population density. Yes, the density of a population in a given habitat during a given period, it fluctuates, changes in 4 basic processes. Of course, we know the population size is not a static parameter, and population size is technically called as population density. It keeps changing or fluctuating with reference to 4 basic processes. The first one is natality or immigration, yes, which contributes to the increase in the population density, and the other 2 is mortality and emigration, that leads to a decrease in the population. All right. So what is natality? So that is the number of births during a given period in the population. Of course, if there are 2 births in a population, that's going to increase the population. So they are added to the initial density. So initially, if the density is X, and if you have 2 births, then the new population is X plus 2, right? Yes, next is just mortality. So number of deaths in the population during a given time. Then immigration. So immigration is entering. So I told you to remember I. So that is moving inside. Okay. So number of individuals of the same species, they come into a habitat from elsewhere during the time period under consideration. So they are entering a population from another population, that is called as immigration. So emigration is exit. They are exiting a particular population and entering a new population. So here emigration, we talk about a population where a particular group leaves the population, and emigration is where you are welcoming a group of population, that is called as immigration. All right. Yes, these are the 4 processes. So how do you represent them? It is with this chart, right? So do you remember this flow chart? So natality is expressed as B. Yes. And immigration as I, mortality as D. Yes. So natality means birth, so that is why it is B, and mortality is death, and that is why it is D. So now I guess you can remember the symbols. Yes. Now immigration is I, emigration is E, immigration is inside, emigration is exit. Remember that way. So your birth and your immigration will add to the population, because in immigration you are welcoming a particular group. Yes. So that is immigration. So birth and immigration will add to the increase in a population, whereas mortality and emigration will decrease the population density. So Ankush, hello, hi. So I guess you're new to my session. So thank you so much for joining my session. So please do like, share and subscribe. So we are talking about ecology. So this is lecture 6 of ecology. So under ecology, we're talking about your population growth. All right. Yes. So how do you represent this in a mathematical form? So you have an equation. So population density. So population density at time t plus 1 is equal to the initial density, that is the population density at time t, yes, plus these 2 add the population. So B plus I minus D plus E. These 2 decrease the population. So the difference between both the sums will give you the population at time t plus 1. Alright, so this is how you represent it mathematically. So this is how you generally talk about a population density. Alright, yes, is this much clear to everyone? So shall I go forward? So then we were talking about your growth models. So why did growth models come into picture? So what were we talking about growth model? So does anyone remember? Yes, of course, we were talking about your logistic growth model and your exponential growth model. But apart from that, what else is important? So does the growth of a population with time show any specific and predictable pattern? So can you conclude, yes, this will grow like this will not grow like this? Yes. So for example, in bacteria, it is easy because bacterial population, you can see it as such. Yes, if in a particular 25 minutes, if they are giving us hundreds and thousands of progeny, yes, you will be able to calculate the pattern. But how do you expect the other population to be? So you have two models. The first one is exponential model and the other one is a growth model. You cannot directly or manually study each and every individual and then talk about a population, right? So you have to do an overall study. So that is done using your growth models. The first one is your exponential model and the second one is your logistic model. So let's talk about your exponential growth. So the resource, the food and space availability is essential for the unimpeded growth of a population. Obviously, so everyone wants unlimited food, everyone wants unlimited resources. Yes, so that is what we expect from nature. That's different. We always keep expecting and we don't give anything back in return. So that is different. But every organism needs unimpeded resources, right? So we always need a stockhouse of resources. We always need something that is to be always stored. So that is called as, so when that is there, when you have undisturbed resources, when you have undisturbed, inexhaustible resources, then the population is going to flourish, right? So ideally, resources in the habitat are unlimited, okay? So, and each species has the ability to utilize its fullest potential to grow. So, when an environment is present, which is giving you abundant resources, which can in turn give you unimpeded growth, it is the organism's responsibility to utilize the resources to its fullest potential. All right. So, such a population is known as exponential or geometric fashion. So, such a population grows geometrically or exponentially. All right. Yes. So exponential growth. So in exponential growth, if in a population of size n, that is nothing but your population density, yes, the birth rates are represented as B. Okay. So it is B and death rates as D. Then the increase or decrease in population size during a time period T. So then how do you represent? Okay. So you talk about the differential terms. So dn by dt. Yes. The population size with respect to time t, yes, so it is equal to b minus t into n. So n is the population density initially, yes. So b minus d gives you the amount of population that has been added recently, so into your population density. So if you substitute this to be r, then dn by dt is equal to rn, right? So here r is the intrinsic rate of natural increase. So R is the intrinsic rate of natural increase. All right. Yes. So this is how it's being represented. So just only look at the red line. So dn by dt is equal to Rn. All right. So this is the population density and this is time. So with respect to time, the population is growing very fast because the resources are unlimited here. So the population is able to show its fullest potential. So dn by dt is equal to Rn. This is in case of your exponential growth. Right? So n is equal to n naught e power rt. So this is also a way of representing your differential growth model. So nt is equal to n naught e power rt. So nt is the population density after time t. Okay. So n naught is equal to the population density at time 0. So r we know is the intrinsic rate of natural increase and e is the base logarithm. So nt is equal to n naught e power rt. Okay, so remember it is the exponential growth model. The next one is the logistic growth model. So no population of any species in nature is at the disposal of unlimited resources to permit exponential growth. So that is exponential growth when your population is at the peak because your resources are unimpeded, because your resources are unlimited. Yes, okay. But in case of logistic growth, we are talking about a practical condition. So no environment is going to give you unlimited resources. Everywhere you have a check, everywhere you have a plus or minus. Yes. That is what it is talking about. So it leads to competition between individuals for limited resources. Now, if no environment is going to have unlimited resources, if there is only limited resources, for example, just understand when you have the entire family pack of ice cream in your house, so you and your siblings do not fight because you have excess for each of you. But if there is only one cup that is present in your house, then you both are going to fight. So then the competition arises. Yes, that is your logistic growth. Yes. So exponential growth is when you have things abundantly. So that is exponential growth. So logistic growth is when you're practical, when you're trying to sort out the issue or when you're trying to sort out how to divide the resources. Yes. It leads to the competition between individuals for limited resources. The fittest individuals will survive and reproduce. So how smartly you fight with your sibling to get that 1 cup of ice cream without making him or her cry. Because if your sibling cries, then your mom will stare at you. Yes, obviously then you will be in trouble. It happens, right? So the fittest of individuals will survive and reproduce. So the next time something like this situation happens at home, so imagine it also happens in nature. Fine? Rajneesh Kumar, hello, hi. Yes, good afternoon. So thank you so much for joining my session. So I guess you're new to my session. So welcome. So please kindly like, share and subscribe my channel. So I teach the entire biology, both class 11 and class 12. All right. Yes. So tell me, how can I help you with biology? Yes. So in nature, given habitat has enough resources to support a maximum possible number beyond which no further growth is possible here. For example, your parents can afford 2 cups of ice creams. Okay, so let alone the 1 cup. So now your parents looking at you fight, they can provide you with 2 cups, one for each one. But beyond that, it is not possible. How much ice cream will you eat? The same with the nature. The nature can support only a limited amount of population. But if the population keeps increasing, then nature is not responsible. For example, today the world population is increasing so much, but the land is in a demand. The forests are in a demand because you need land, you're trying to clear up forests. So your nature can support only a maximum number of population who can ensure or utilize the resources available. Okay, so in nature, a given habitat has enough resources to support a maximum possible number beyond which no further growth is possible. All right, yes, so this is called as a carrying capacity K. Okay, so what is the carrying capacity for nature for a particular population? So the carrying capacity for species in that population is, so what is that? So it is here. So this is your logistic growth. Okay. Hi Shimpi Dubey. Yes, good afternoon. So thank you so much. Yes, I am good. How are you doing? Great. Yes, I am waiting for you to become my student. So become my student soon. That's really sweet of you to come and talk to me. So this is your logistic growth. Fine. So dn by dt is equal to Rn. So R is still the intrinsic growth rate and N is the population density. But you have here what is called as the carrying capacity. A population can, in nature, a particular group, in a population, in a ecosystem, in an environment, only limited number of population can survive. That is K minus N by K. All right. So that is called as the carrying capacity here. So then, a population growing in a habitat with limited resources, initially it shows a lag phase followed by phases of acceleration and deceleration. So what does this mean? So finally, a symptom when the population density reaches the carrying capacity, a plot of n in relation to time results in a sigmoidal curve. For example, it is something like this. So initially this phase is called as a lag phase. Okay, initially it is trying to adjust with the competition, so it is the lag phase, and then you have a steep growth, that is your exponential phase, and again you have a decline. So you have a stationary phase and then you have a decline phase. So in a logistic model, so this is what happens, you get a sigmoidal curve. So this is the most practical one. So in an environment, yes, of course you have competition. So what are we competing for? If you take human population, we are competing for land. This is my house, this is my area, right? So you're trying to compete. So initially, by the time you get accustomed to the competition, you have an initial slow phase. You're trying to sort how am I going to work further, right? Then you have a rapid growth phase, that is exponential phase. You know how to deal with the situation. And then you have a stationary phase, you're satisfied, and then the growth declines. Yes, so that is what happens. The type of population growth is called as the Verhulst per logistic growth. Verhulst per logistic growth. All right. So it looks something like this alone. Yes. So initially it has a slow growing phase, that is called as the lag phase. Then a good exponential phase. Then you have a stationary phase like this, and then it starts to decline. Yes. Your board exam is on 17th. So today is 8th. Oh my God. So not even 10 days. So please do prepare well. So all the best. Okay. So stay peaceful, study well and do well. All right, Shimpi? Fine. Yes. So This type of population, that is your logistic population, is dn by dt is equal to Rn into carrying capacity minus the population density by the carrying capacity. Okay, so that gives you the logistic growth rate. So please do remember the formula in both the cases. Fine. So moving, so with this we are done with the growth models. So talking further about life history variation. So how are the organisms adapted to a particular population? So for example, now we have been talking about a population, whether the population is stably increasing or declining. So how does a particular group of organisms contribute this? So that is life history variation. So I told you the size of a population is never a constant number. It is not a static parameter. So how do you know? So what are the possibilities? So the population evolved to maximize the reproductive fitness, that is called as Darwinian fitness, right? So every progeny, so every group of individual tries to persist their progeny, right? So they just want their progeny to persist and pertain in the future. So that is called as a reproductive fitness. How well they are able to reproduce in a given environment and how well they are able to survive in the given environment. So that is called as reproductive fitness. So always fitness comes in terms of reproductive fitness here, that is your Darwinian fitness. So when I'm talking about fitness, the intrinsic growth rate R should be high. So you should have a high R value, the habitat in which they live. Fine. So under a particular set of selection pressure, organisms evolve towards the most efficient reproduction strategy. For example, when you are put under pressure, you come out with very, very interesting solutions, right? So that is why they say only when under pressure people tend to think right, okay? Because they have to prove themselves. If not, then they will lose their life. So in such a cases, they come out with wonderful solutions. So similarly, when an organism is under a set selective pressure, so they evolve efficient methods or strategies for reproduction. So what are they? So some organisms breed only once in their lifetime. So whenever the resource availability is maximum, they tend to breed only that time. For example, your specific salmon fish, your bamboo, they reproduce only once during their entire lifetime. So others breed many times during their lifetime, like your birds and mammals. Yes, for birds and mammals, there is no particular time. For example, a dog breeds whenever it has its own seasonal timing. Yes, it does not depend on nature. It can reproduce during the entire lifetime. Yes, Krishna Kumar, hi, hello. So thank you so much for joining my session. So do like, share and subscribe. So we are talking about lecture 6 of ecology. Alright, so some organisms produce a large number of small-sized offsprings like your oyster, pelagic fishes, etc. So they reproduce only once at a single time. They ensure that they have enough number of eggs so that their progeny sustains for long. Alright, so these are the different types of variations that is present in an organism to sustain or survive in an environment and prove its fitness level. Okay, yes? So Aniket, Aryan, hi, hello. So once again, you're also new to my session. So thank you so much for joining my session. It's great to have you guys here. Come on, quickly like, share and subscribe. So I'm talking about lecture 6 of ecology. All right. So we are talking about life history variation. So long we're talking about how in a particular population you have your logistic growth and exponential growth, how a particular organism will afford to live in a particular population, in a particular habitat. Yes, super fast NEET, nearly after a month you're coming to my session. So it's great to have you. So thank you so much for coming. Yes, I hope you're fine and you're busy with your schoolwork. Yes, so please do like, share and subscribe. So thank you so much, super fast NEET. Okay. So how does the organism work under a set of selective pressures? That is, they evolve efficient reproductive strategy. For example, in organisms that breed only once, maybe they are in a situation where the environmental pressure is too high, where the environment is unfavorable to breed the entire lifetime. Okay, so example is your specific salmon fish and your bamboo. The next one, others breed many times during their lifetime, that is like your birds and mammals. And some produce a large number of small-sized offspring called as oyster, pelagic fishes, etc. Yes, so others produce a small number of large-sized offsprings like your birds and mammals. So birds and mammals reproduce only in a limited number, but when they do, their impact is very high. Of course, we are multicellular organisms, right? So which is desirable for maximizing fitness? So you have so many types of variation where organisms reproduce only once during their life cycle or throughout their life cycle, or in one time they give rise to a lot of progeny. So which one is desirable for maximizing fitness? Of course, all of us together coexist in an environment right now, right? Yes, you also have birds living, we also have mammals living. So all these are efficient in their own way to maximize their reproductive fitness. So ecologists suggest that the person who studies about ecology is called as ecologist. They suggest that the life history traits of an organism have evolved in relation to the constraints imposed by the abiotic and biotic components of the habitat. So just like I was about to tell you, so all these adaptations or all these variations of the organism is due to the restrictions imposed by the abiotic and the biotic factor on that particular organism. So if you ask, why is specific salmon fishes breeding only once in their lifetime? Because that is due to the impact of the abiotic and the biotic factors that is present. Maybe the body is designed in such a way. Maybe the environment that it is living in is making it reproduce only once. Okay, so all these plays an important role. Understood? Is this much clear? So evolution of life history traits in different species is currently an important area of research. So yes, of course. So why is the organism reproducing only once? So why are the other organisms reproducing so many times? So what is the difference? We say all living organisms are made up of cell, but why are they designed differently? So that is the question of the hour, and that is what your ecologists are trying to find. All right? Yes. So now we are entering into the last topic of your chapter, that is population interaction. How does a population interact? It's not that how you and I are interacting. Of course, we interact through class, and if you're interacting with your friends, you use your phone, you use your video call, etc. All that is there. But how does one population interact with another population? For example, how are we interacting with microbes? Any idea? Of course, your cecum in your small intestine houses a lot of microorganisms. So that is also one way of interaction between microorganisms and humans. But yet alone humans and microbes, there are a lot of other population living in the earth, living on earth. So how do they interact? So that is population interaction. Okay, so for many species, the minimal requirement is one more species on which it can feed. Yes, for example, for all the non-vegetarians here, if you alone live, it won't be enough, right? So you also need another organism whom you can kill and eat. That is what every organism thinks. So, for example, for a tiger, it needs a deer. For a lion, it needs a fox. So, the minimal requirement for those organisms is the presence of another species on whom it can depend on, right? So even a plant species which makes its own food cannot survive alone. Of course, it needs soil microbes to break down the organic matter in soil. Of course, it needs microbes to fix nitrogen. Yes, and it also needs them for inorganic nutrient absorption. So we have interspecific interactions, that is between species. So between plant and microbes, between the individual, so between a bacteria and a fungi, between a fungi and algae. Yes, so you have interspecific interactions that arise from the interaction of population of two different species. That is interspecific interactions. So this interaction between two species, it can be beneficial. For example, you interact with mosquito. Yes, so that is also a type of interaction. So mosquito is a different population, you are a different population. So how is your interaction? So the interaction could be beneficial, it can be detrimental or neutral, neither benefit nor harm. Okay, to one of the species or to both. Okay, so here is a, yes, so here is a list of how your population interaction happens. So plus sign involves it is beneficial, minus sign involves it is harmful. Okay, so when you talk about the type of interaction, that is mutualism, so mutual is both. So when I say there's a mutual understanding between the student and teacher, I understand you and you understand me, that is called as mutual understanding. Okay, so you have two species. This can be any species, this can be any species. Okay, it can be microbes, it can be animals, it can be plants, it can be bacteria, anything. So species both A and B benefit, so it is called as mutualism. All right, the next one is competition. So if there is only one bird, okay, and the cat, so say if there is only one fish, the cat is also targeting and your tiger is also targeting, yes, the competition is high. Yes, so in a competition, both the species are harmed, not that they are benefited. Yes, so that is called as high competition. Okay, next is predation. Only the predator is benefited. For example, when I say predation, so tiger and deer, only the tiger is benefited, the deer is not benefited, so only one species is benefited. All right, the next one is parasitism. So when your mosquito bites you, the mosquito is introducing sporocytes inside you, right? That's the plasmodium. So you are being harmed and the mosquito is taking the advantage because it is sucking your blood, right? So that is parasitism. The next one is commensalism. So commensalism, again, one is getting benefited, the other is neither harmed, neither benefited. That is commensalism, okay? Then the last one is amensalism. So one is getting harmed, whereas the other is neither getting benefited nor harmed, okay? So these are the different types of interaction. So I want you to remember all these interaction. So what is mutualism, competition, predation, parasitism, commensalism, amensalism, along with examples. So if at all they're trying to confuse you with the questions of your organism and population, they might do in this area. Yes, for each case you will have to remember the examples. Of course, mutualism is understood plant and microorganisms because plant gives them food and your microorganisms fixes your nitrogen. Yes. But from competition, predation, parasitism, commensalism and amensalism, you will have to remember what is the mechanism. So how the organism is being adapted to face that type of interaction and what are the examples. Alright. So now I go to my previous slides. So both the species benefit in mutualism and both the species lose in competition in their interaction with each other. Alright. So in parasitism and predation, only one species benefits. Yes, I am literally explaining the tabular column. So interaction is detrimental to other species. Okay, so in parasitism and predation, only one of the species is benefited. So there is no interaction where one species is benefited. So the interaction where one species is benefited, the other is either benefited or harmed is called as commensalism. So in amensalism, on the other hand, one species is harmed, whereas the other species is unaffected. Yes, so we are going to talk about the examples of each of these in detail. So here we are going to talk, so mutualism and competition is pretty understood, but now we'll talk about these three, that is predation, parasitism and commensalism. So PPC. Okay, so they share a common characteristic, that is interacting species live closely together. Yes, explaining the tabular column. So we have so many types of interaction starting from mutualism, competition, predation, parasitism, commensalism and amensalism. Alright, so what is mutualism? So mutual is mutual understanding. When both the species are getting when both the species are benefited, it is called as advantageous. So plus sign here represents that they are getting benefited. So minus sign indicates they are being harmful, they are being harmed, and 0 represents neither of the two. So here both your species A and your species B are getting benefited. So that is called as mutualism. Alright. Then, so in case of competition, both of them lose. So none of the species getting benefited. Yes. Then in case of predation, so imagine a lion attacking a fox. So only the lion is getting benefited, the fox is not getting benefited, but instead the fox is getting harmed. So only one species benefited in case of predation. In case of parasitism, so your mosquito is a parasite. So when your mosquito bites you, the mosquito is advantageous, the mosquito is getting benefited because it's sucking your blood. But in turn, you feel itching, you feel irritation, and sometimes the sporocytes of your plasmodium also enter your body. So one organism is getting harmed. Then commensalism, where there is interaction between two species, but one is being benefited, the other is neither benefited nor harmed. Okay, so in case of amensalism, there is interaction, but one group of species is harmed, the other group is neither affected. It is neither benefited nor harmful. Alright, so these are the three types of interaction. So first we'll talk about these three in detail: predation, parasitism and commensalism. Alright, yes? Okay, so these three share a common characteristic. The interacting species live closely together. So if you are talking about parasitism, so humans and mosquitoes are very nearby. It's not that if you have to have a mosquito bite, you have to go to a forest to get a mosquito bite, right? So we live very closely together, that is predation, competition. So here, when I'm talking about predation, so we'll also talk about competition and then we'll move into parasitism, alright? So next class, I'll start with predation. So I'll stop right here. So next class, we'll try to finish where I'll talk about your predation, parasitism, commensalism and amensalism. Alright. So I'll try to finish the chapter on Wednesday. So meanwhile, tomorrow we'll be talking about cockroach. We'll try to finish off cockroach in one lecture, and very soon we'll enter into human physiology. All right? Yes? Okay, so thank you for being a wonderful audience. So if you have any doubts, please make a note of it, and tomorrow in class we can discuss. Yes? So thank you so much. So have a great evening. I will meet you tomorrow. So bye until then, and this is me signing off. So take care and bye-bye.